I'm going to go ahead and get started. Good morning. So gigabytes per day to terabytes per day, terabytes per year to petabytes per year. The global Earth-observing satellite system of systems is ever expanding. For example, data volumes have grown by about 2 orders of magnitude between the last generation of operational Earth observation satellites and the new generation coming into operations now. I picked just a couple of examples to show you this big expansion in the volume of data. So the first plot, if I can get the chart to change. There we go. So the first plot gives a sampling to compare data volumes from previous and new generation geostationary operational weather satellites. So you can see the tremendous increase in the data volumes. The second provides a similar comparison for selected polar observational weather satellites. This trend will continue as more nations contribute and satellite capabilities grow. And what this shows is that we are truly in the big data era in satellite observations. Today, with the help of 4 distinguished panelists and you, we are going to explore from up there to down here, big space data driving sustainable development and economic growth on Earth. I'm Harry Sakanik, your moderator. We want to examine how the dramatically expanding diverse big space data sets from satellite-based Earth observations can be leveraged to support global sustainable development and economic growth on Earth and ultimately beyond. Having the best choices for our common future depends on putting space observations to work down here on Earth through efforts to raise living standards and give more people the opportunity to realize their potential. This economic growth must be socially and environmentally sustainable if it is to translate into permanent rather than transient benefits. Ultimately, the same sorts of challenges we face in ensuring sustainable development here on Earth will be ones we'll need to face as we start to scale up exploration and development even of other planets. Mastering these sorts of challenges will help us create the necessary conditions for realizing the goals we have now while creating space for ideas that have not even been thought of yet. So now I want to talk a little bit about how we're going to do this. The way we will explore this hot topic, particularly big data is a very hot topic these days, is that each panelist will present their perspective. After all have spoken, I will ask each a provocative question, and then I will pose your questions to them. At the end, I will summarize the key takeaway messages. To submit questions, please write them down on cards that are provided by the volunteers who are wearing blue shirts that are positioned around the room. They will provide your questions to a colleague who will select the most interesting, which I will then pose to the panelists. Everyone got that okay? All right, let's begin. Our 4 panelists represent 3 points of view. First, those of an international agency societal development goals expert. Second, a national government agency big data expert. And third, the commercial perspective. Now for a little background that's important to be aware of, which you may not know. The United Nations Sustainable Development Goals, officially known as Transforming Our World, the 2030 Agenda for Sustainable Development, embody the societal needs which big Earth data can help address. These 17 global goals were spearheaded by the United Nations through a deliberative process involving its 193 member states as well as global civil society, and were adopted in September 2015. Now let me introduce our first panelist, an International Agency Societal Development Goals expert, Mr. Aditya Agrawal. He is Director of Data Ecosystems Development in the Global Partnership for Sustainable Development. He leads the GPSDD program in developing an ecosystem approach for harnessing the data revolution for sustainable development while also supporting the development of in-country data ecosystems using the whole-of-government and multi-stakeholder approaches. The GPSDD includes more than 200 organizations across sectors from around the world who are working to achieve the 2030 Agenda for Sustainable Development. Aditya?
Good morning, everyone. It is a real honor to be here. This is a different type of conference for me, so really trying to see what some of the work that you're all doing and how that intersects with the Sustainable Development Goals has been very interesting, and thank you to the organizers for this invitation. It's not working. There it goes. Okay. As Harry had said, I work for an organization called the Global Partnership for Sustainable Development Data, which is really focused on the Sustainable Development Goals. Previously, the world was working towards the Millennium Development Goals, which were only focused on developing countries. So the transition that's taking place right now with the Sustainable Development Goals is that it's a universal agenda, which means all 193 countries under the UN system are working against that. We're also at a different point in time when data is becoming more dynamic, more easily accessible, and people have more access to mobile phones than electrification, for example. And so with the SDGs, which span across 17 different goals, which cover everything from agriculture to water to deforestation to basic needs around health access, population, and gender data, there's 230 indicators that are making up the overall framework, which has huge data considerations behind it. But when we look at the data landscape across the world, there's still many of the same issues with data that we've been talking about for a number of years now. It's often not available, it's not dynamic, it's not disaggregated to the extent that allows for better decision-making to take place, and there's still a lot of issues around its accessibility, how open it's being made, and how it's actually being used. And so when we're thinking about why do we need data, what do we want it for? Ultimately, we want it to improve decision-making and policy-making. We want citizens to be better engaged with that information so it has an impact on their lives. And we want to be able to create ecosystems that really empower innovation and entrepreneurship. And so within the context of the SDGs, there's a data revolution that's currently taking place. The intent is to really get governments and civil society and private sector working together to unleash innovation and be able to get at information that's more dynamic, real-time, and disaggregated. So within that context, we're working with a number of organizations across different types of data communities. So Earth observation data, working with some core partners at the Group on Earth Observations, NASA and the European Space Agency, looking at how citizens are able to generate data and integrate that with more official data. Privately held data, looking at call data records and also how that integrates with other data sources, and really trying to promote the use of open data and open ecosystems as a way to deliver information. So the Global Partnership for Sustainable Development Data, it was called for in 2015 when the Sustainable Development Goals were launched by the UN. It's an organization right now that's made up of over 200 other organizations across all sectors, and it's currently housed at the United Nations Foundation. Much of the work that we're doing goes across 3 different tiers. One is that we're trying to put data on the political agenda and get countries to get political commitments on the importance of data for development. Work with all of our partners and really understand what the demand is on the ground to be able to better connect demand and supply, and then really create an enabling environment that lessens the friction for how data flows, when looking at things like APIs and protocols and standards. And one of the core programs that we've been working on that really focuses on the demand side of the question is a process that we've outlined around data roadmaps for sustainable development. We're working both at the national and subnational level to really implement a whole of government and multi-stakeholder approach that emphasizes the use of the data revolution as a way to really understand how all these new alternative data sources can support the challenges that countries are facing. It's both a political and a technical process, and these are the countries that we're working with right now, which are really looking at how to use this international framework for the sustainable goals and their targets and put that into a localized framework that really considers what the priorities are at the country level and contextualizes the international framework to something that's more national. Now, from the global partnership perspective, and I guess a little bit of context around the SDGs, is that it's within the UN Statistical Commission, which means that at the country level, it's the national statistical organizations that are mandated to do the reporting and monitoring behind the SDGs. From a data revolution perspective, we're trying to see how these alternative sources, like citizen-generated data, privately held data, open data, and so on, can really be integrated with the official statistics and do it in a way where we're not just thinking about data for reporting and monitoring, but what is the feedback loop of that data such that you're able to really empower better action and decision-making around it. And so a few examples. This is Colombia. So what many countries are doing right now is they're going through a data gap assessment to better understand what is their situation with the data that's needed for the SDGs. So Colombia, which is arguably one of the most advanced countries in their response to the SDGs, especially in the context of the data revolution and innovation, created this traffic light approach to create a framework for where the key gaps are. And so this is telling you that they have about 54% of the data that's needed, with partial information being around 30%, but 16% where they just don't have the data. So this, within that bottom 46% is really where they're looking for better support from other organizations and how you're able to drive innovation around the data needs there to fill those gaps. With the group on Earth observations, there's broad acceptance that Earth observation data has a huge role to play when we're thinking about the data needs for the SDGs. So the group on Earth observations now has taken the full SDG framework and basically mapped out where Earth observation data can be best applied. And so with Colombia, we've been working very closely with organizations like NASA and the Group on Earth Observations to go through this iterative approach to better understand what the country level needs are and then bring those needs down to the country level and have an interaction with institutions that are working on those particular problems. And so these issues range from urban resilience to deforestation, land use and cover change, and water resources. But the interesting part about this type of an approach is that what it often surfaces is some of the institutional issues across agencies and how they're able to better support data sharing and access, where some agencies have the particular expertise, but that expertise in the data is just not being shared. So for example, in Colombia, they do have a data cube that's been established, but it was only accessible to the Ministry of Environment. Through this dialogue that took place, that access then opened up so that the National Statistical Organization also had that information, and now they're able to more readily solve for some of the problems. And so working with a number of different organizations, including the University of Florida, Season at Columbia University, we're looking at all these different methods that are that have been well developed within the geospatial community and bring that into national statistics, like different types of population mapping, looking at marine biodiversity observation networks, with the University of Maryland and CEOS and NASA, looking at deforestation models and water observations. And these are all methods that are readily accessible, but within a different context. We're trying to make those more applicable at the country level in response to the SDGs. And so last week I was at the UN General Assembly, where we were working very closely with our country partners to identify additional ways in which the global partnership and its partners may be able to better support. There's a lot of the countries right now over the next 2 to 3 years are going to be doing their population censuses and their agricultural censuses, some of which have not been done anywhere from the last 10 to 40 years. And so trying to better understand how Earth observation data can be applied to an intergovernmental network for open data in agriculture and nutrition, for example. In Kenya, who's facing a major drought right now, there's huge food security issues. The minister there has a very simple question. He just needs to know where the agricultural farms are and where the farmers are. We should be able to provide that information. Looking at the establishment of data cubes, you're going to hear much more about that from Stuart, who's going to be the next speaker, and really trying to get much more granular and dynamic about the data that's being made available, such that it's also more cost effective. From the partnership perspective, what we're trying to do is take all of the learnings that are happening through this process and be able to create a number of different resources and best practices and guidelines that we make available to all of these countries in a way where we can experiment and where we can pilot many of these methods and then scale them across different countries. We're also looking to work with different partners to create a data infrastructure that really allows for bringing together some of these new data sources in a way that it empowers the developer community to create apps and visualizations, essentially trying to get at data for action and decision-making in a more robust way. So with that, I want to conclude. I just want to end by saying that we have 13 years left to achieve the Sustainable Development Goals, so the time for action is now. It's going to take a collective effort to do that, and Earth observations are going to be more and more increasingly important in that process. Thank you.
Okay, our next panelist is a national government agency big data expert. Dr. Stuart Minchin, Chief of the Environmental Geosciences Division of Geosciences Australia, is the panelist. This division consists of about 200 staff and includes the National Earth and Marine Observations, National Geospatial Information, and Groundwater branches. It is the center of expertise in the Australian government for environmental earth sciences issues and the custodian of national environmental geoscience data, information, and knowledge. Stuart? I want to remind you all also, if you have questions, flag a volunteer.
Thanks very much, Harry. So we've heard from Harry about the challenge that's faced by the volumes of data that we're getting from space, big space data. And we've also heard from Aditya about the real challenge that the world faces in creating sustainable development and meeting the Sustainable Development Goals. What I'm going to talk to you about is an Australian innovation that we think can help us with both of these challenges and has global applicability, and it's called Digital Earth Australia. Let me give you a bit of background. So we've been collecting satellite information over Australia for the last 40 years through our ground station at Alice Springs, but we weren't making very good use of this information. It was going into archives, and it really wasn't, the richness of the information that existed wasn't being used. So what we did with our partners CSIRO and the National Supercomputer Facility, the NCI, is we moved all of that data onto the National Supercomputer Facility, and we turned those regular overpasses from satellites over the last 40 years into a very dense temporal stack of calibrated, orthorectified, cloud-masked and atmospherically corrected measurements. What that's enabled us to do is to create an enormous analytical engine that we can now ask questions of in a data mining sense. So we can run algorithms across this analytical engine and look for the presence of water, which is the map that you see before you, which shows you the frequency with which we've seen water in the last 30 years across the entire Australian continent. We can look for vegetation changes, we can look for urban development, we can look for bare soil, we can look for coastline changes, we can look for forestry changes, bushfire scars, just about anything you can imagine seeing with your eyes, we can design an algorithm to extract that from this data. And we can not only show you what that outcome is today, but we can show you what it's been for the last 30 years. So this is a real game changer for us. And let me take you through just a few examples of those products. So the first one I want to talk about is this water observations from space, which is looking at the frequency with which we've seen water across the Australian continent. Now this product goes back now for 30 years of data. It's at 25 metre resolution across the entire Australian continent. And just a couple of figures to note here. The data that went into this came from 300,000 individual Landsat scenes. So two things to note about that. Once upon a time, you had to pay for that data. Until the Group on Earth Observations influenced the US government, and the US government agreed to make that data free and open, you would have had to pay $1,000 per scene. So that product would have cost $300 million to generate, and now it is free. So this is a fundamental change. We would not have attempted this without free and open data. The second thing to note is that doing this analysis the old-fashioned way of downloading individual satellite scenes from a server, it would take you 20 years to download the data before you could actually do the analysis. We can now generate this product in 3 hours at the National Supercomputer Facility. So what does the product look like when you actually delve in? So this is available now on the web. You can actually explore this yourself. And if you zoom into any part of Australia, you can actually see the frequency with which we've seen water over that 30-year period. So in this map, what you're seeing is in blue, areas that have been wet for most of that period, in green, areas that have been wet for some of that period, and in red and yellow, areas that have only been wet once or twice. These are the natural floodplains. You can interrogate this by clicking on any individual 25-metre pixel, and it will tell you how often we've observed that pixel. In this case, 527 times over that 30-year period. It's been wet only 16% of the time. However, we can also tell you when it's been wet. So the red trace at the top is when it's dry, and the blue trace is when it's wet. And what you can see from here is that there was a little wet period in 1990, another one in 1996, and then in 2010, this particular pixel became very wet. What happened there is that they actually built a dam on that location. So here we have a product that tells us how often our wetlands have been wet for the last 30 years, what areas have been flooded, and how water has been managed in the landscape over that entire 30-year period, and this is available for the entire continent of Australia. A really powerful capability, and it feeds straight into one of the SDG goals, which is presence and an extent of water-related ecosystems. What we didn't realise at the time is we had created a coastal change detection tool, because the presence or absence of water occurs with every tidal cycle. So you can actually look around the coastline of Australia, and in some cases you'll see the areas in the intertidal zone where it's sometimes detected as land and sometimes as water. But you'll also see areas where it goes from always being detected as land to always being detected as water. This is coastal erosion at work. Likewise, you can see places where it's gone from being always water to always land, and this is coastal deposition. So you can actually measure objectively for the entire coastline of a continent how our coast has changed over the last 30 years. And you can actually show this in animated form at any point in the coastline. So this is a 30-year history of that island that I was showing, and you can see the process going on of deposition of the sand and the erosion going on that coastline in active form. So really powerful techniques for showcasing how change is occurring. All of those previous examples are just one algorithm which is looking for presence or absence of water, but you can run any algorithm over this data that has ever been applied to optical satellite imagery. So here's another example where we're looking at an algorithm that's looking at fractional cover, the percentage of green vegetation, dry vegetation and bare soil in any given pixel. We're looking at that little black box in the centre of the screen. What you'll see here is the pattern of cropping for this paddock in South Australia, actually. And what you're seeing here is a pattern of an annual wheat crop, where each year the crop gets planted, it greens up, it dries off, it gets harvested, and then next year another crop is planted. You'll see in that pattern that some years are more vigorous than others, and there's a big change in around 2005. What happens there is that field got turned into an almond plantation, and you go to a deciduous winter tree crop with growing biomass, as you can see. So this is an entire record for the last 30 years of that field, but we can generate that for every field on that farm, for every field on the continent from this information. So really powerful. What's really exciting is that we can do this for the world, right? Because all of the examples I've just shown you are based on free and open data that is available globally. Right? So this data exists globally. All we have to do is arrange it in this way, and all of these products that I've described to you can actually be run over Africa, over South America, anywhere in the world. And that's a real opportunity, and Aditya mentioned that there is work going on with data cubes in other places, including Colombia. They're using our code base to actually apply this. So I'm going to finish now with a very short video which explains Digital Earth Australia and shows you a few more examples of what it can be used for.
The Australian Government is investing in a world-first analysis platform for satellite imagery and other Earth observations. Building on the globally recognised Australian Geoscience Data Cube, Digital Earth Australia will provide a new approach to organising, analysing and storing vast quantities of data. Today, it translates 30 years of Earth observation data into information and insights about the changing Australian landscape and coastline. When fully operational, Digital Earth Australia will provide us with new information for every 10 metres square of Australia every 5 days. Information on issues that affect all Australians: environmental management, population growth, smart cities, coastal change, disaster management, resources, agricultural productivity, food security, and water sustainability. By providing easy access to free and open Earth observation data, Digital Earth Australia will unlock innovation and capability across industry. Digital Earth Australia. Big data for a big country.
That tagline was created by our Prime Minister, actually. So you can find out more at these website locations, or come and see us at the Australian Government booth in the exhibition. Thank you very much.
Okay, our next two panelists provide the commercial perspective. Our third panelist is Greg Milczynski of Synergies. He studied physics and co-founded COSI Lab at age 21, a company developing control systems for particle accelerators and large experiments in physics. In 2008, Greg moved to become CEO and co-founder of Synergies, specializing in software for advanced geospatial applications. Greg, ready?
Thank you. So you might have heard about our Sentinel Hopper. You maybe came across Sentinel Playground or EO Browser. But basically, we work with the companies and institutions who integrate our web services in their web applications to make it easier for them to get the big data in. And there are a couple of applications around the world, mostly related to the precision farming, land administration, security, and also environmental monitoring. For example, we have a Global Forest Watch using our services, and Greenpeace, as well as the FAO. Just to give you an idea of the scale, there are about 1 million requests processed every day with our data. So what I want to talk about are the free data, Landsat and Sentinel, which are kind of magical. Basically, we get an option to get an insight into each and every part of the world every week. It's really something that a couple of years ago, it was science fiction, and I think it's really, really cool, but still most people don't know about it, and I think that's a pity. What probably happens is that the beauty of these missions, the vast amount of data that they generate every day is also their jinx, because like remote sensing experts, who are the very people who know best how to work with it, they look at the data and they say, wow, how can I manage that? And then what they usually do is they limit themselves to a couple of scenes, and then they process it, but before they finish, there are new data available which they have missed. And I think that's something that we need to address, and this is what I'd like to talk about. And first, I would like to talk with about the data providers. What I think is really important is that the data become really easily accessible to the users. And now, opening the data, opening the public data was probably the most important step that happened in the field, but it's not enough. Basically, we need to have the data available easily and efficiently, and because the downloading the data in scenes, like what Stuart mentioned, this is something that happened in the past. Today, people want to get access to just the data, the area that they are interested in, but they want to get it multi-range, multi-year data. And this goes the same for the commercial providers. I mean, the cost of the square kilometer is somehow feasible, but if they force you to buy the large area which you don't need, and maybe, God forbid, that you need to do this manually so that it takes a couple of days to get the data, it kind of defeats the purpose. So I think that what we need is business models and API from the data providers that allow us to get exactly the data we need in an efficient way. Then going to the remote sensing experts. I mean, they gathered knowledge on how to get something useful out of the pixels for decades, but still most of the procedures that we have now require some kind of manual intervention, and they only work along the limited area. I think this is now something that we need to change. We need to work globally, and I think we can do that. And I mean, maybe globally is too ambitious, but at least regionally. And obviously, we need to have a completely automatic procedures because there's simply not enough experts in the world to process everything that we would like to process. And then going to the application developers, going back to the experts, what I think is happening is that the field is going into statistical processing, where companies are using machine learning to automatically extract the data. And I think that the remote sensing experts need to adapt to that, and they need to go to statistical processing as well, because soon the field will be full of mathematicians who will generate a good enough information, not perfect, but good enough, but for a fraction of cost. And this is where we come to the application developers, who are now very keen that they have the capability to run off, I don't know, 10,000 CPUs, and then they run it for a day and they get a nice result. But that's fine, but this costs thousands of euros. And if you don't have somebody who will pay for that, that means that your business model doesn't work and that what you're doing on will not happen for a long time, but we need sustainable applications. So what we need to do is we need to have applications which can scale globally from the business and technological perspective, and so that, that we can explore the business models around the world, because it's simply not possible to do it in one country. And the other thing that we need to do is stop trying to do each and every piece of the puzzle ourselves, because there are so many tools available out there which can make our life easier and more effective. I mean, Brandon will be talking about Amazon. You can go to Amazon and you have access to the full Landsat and Sentinel archive more or less for free. I mean, what else can you wish? Or you go to our Sentinel Hub services and you can make an application with a full data archive in 5 minutes. I mean, so you really have lots of time available to build your idea and to build features for your end users. Now, the Earth observation field was a game of big industry players and research until recently, but not anymore. Now, actually, anyone can engage, either just by going to, for example, Sentinel Playground and observe their area of interest throughout the year. I mean, they get the data more or less on a weekly basis, and they can then share their findings with others over Twitter or something else. Or they can go and build the application for other users. Now, this is really not that difficult anymore. I mean, we are a small company, and a group of about 5 people did what you're seeing here. Now, imagine if every of the group of the world would do something similar, work on the applications based on the EO data, which are now out there. Imagine if each one of you would go and build something with these tools. Thank you.
Thanks, Brandon. That was great. Okay, I want to remind everyone, if you have questions, just flag one of the volunteers. Okay, our final panelist is Brendan Boofler, Manager of AWS Research Cloud Program, Amazon Web Services based in London. Brendan has 25 years of experience in the global tech industry, creating very large systems in high-performance environments. He has been responsible for designing and building hundreds of HPC all around the world, and has quite a number of his efforts listed in the top 500, including some that have been placed in the top 5. He joined Amazon in 2014 to accelerate the adoption of cloud computing in the scientific community. Brendan?
Thank you. Do I get the wrong direction? So thank you. It's actually rather exciting to be invited to come home for a talk, which was fantastic. So thanks to Gunter for being the organizer in that.
it's actually kind of appropriate that I come last, because I think the infrastructure that we build and provide is kind of the substrate to a lot of this activity. And it actually, again, the fact that we come last actually points out the importance of what all of these other guys are doing, and makes us, sort of humbles us a little bit with how much really interesting stuff that we're able to support. So, in terms of my, and I'm going to keep these comments brief, in terms of my thoughts about, where we can have the most impact on achieving these sustainable development goals, and, and supporting all of the folks that are leading us in that direction, I think the places, the two levers that we have as a company, as a commercial organisation in this market, are these two that I've put up on the screen. The left one is as old as science itself, quite literally. It is the scientific method. The task that we have is actually to enable people to be able to do computational experiments, try out new techniques, experiment with algorithms and so forth, but to do so very quickly. The scientific method is it's amazing. It works really well. You start with an idea, you improve it. It's an iterative method. Failure of an experiment is a data point that tells you something, and you feed that back into the machine, and you get a constantly improving model of the world. The more laps that we do around that circuit, the closer we get to the truth. And so it's, our task is to try and work out how we can get people doing more laps around the scientific method circuit faster. And with more accuracy, and being able to do it cheaply. So, a big important part of our mission is actually to use the cloud to do things like lowering the cost of doing an experiment. We think that it should be cheap, fast, and easy to do an experiment, and that's one of the levers that we think we can pull where we can have a big impact in this space. So the other one is actually sharing infrastructure and sharing data. So these are just some examples of some of the large public data sets that we host in the cloud, and Gregor mentioned it a minute ago. The ability to go and plunder these data sets, which are very large scale peta-class data sets. When I was working in astronomy and physics, back in the earliest parts of my career, we used to carry around suitcases full of tapes. And that's an interesting way of transporting data, but nowadays that's just simply unsustainable. We actually have a truckload of disks now. We can actually deliver you a truckload of disks and take away 11 petabytes of data. But the reality is that moving data around is actually a really inefficient thing to do. Computing has become radically cheaper in the way to, in terms of generating data. Satellites are generating a ton more data. Cost of storing that data is, is crashing as well. All of these are good things. Biggest difficulty is actually moving the data around. So one of the levers that we can pull with the cloud, and using this as a pretty interesting technology in this space, is that we can offer folks the venue for the data to reside and to come and bring their workloads. And what that actually means is that it means that we're sort of federating the cost or defraying the cost of accessing that data. So as Gregor mentioned before, there's so many workloads that he's done that he probably couldn't have been able to do if he had to actually have access to a petabyte of storage, and he had to know somebody at NASA just to get a copy of the USGS Landsat data. If you've got a $5 workload you need to conduct, that's kind of a pretty impossible barrier to entry. So aggregating a lot of these very large public data sets means that people can spend their money, instead of spending it on crap loads of storage, they can spend that on a whole lot of compute and actually get some insights out of the data. I make this point all the time that the infrastructure that we need to be building is actually data sets, tools, and techniques. And those are the things that I really hope that we can actually support. I think we've got some great examples here on stage of folks using different platforms to do exactly that. Getting it out there and putting those very sophisticated tools in the hands of people who can make interpretations of the data is actually the key. So all of that, I guess, is a precursor to, just a few examples. You can go to this site and you can have a look at some of the few examples of how we're supporting that mission. Anyway, with that, I guess my last point will be that will be just to remind you that I think the mission that we all have is to Well, the mission that I have in supporting what you are doing is to lower the cost of experimentation and lower the cost of knowledge. And with that, I will shut up. Thank you.
Okay, now we're going to move into question and answer time. I'm going to take the opportunity to just do a few lead-off questions, and then we'll turn it over to the audience questions that we've received. Okay, so the first question I have is for Aditya, and it is, what is the one thing you would like to see governments do more of relative to their Earth observations, and what is the one thing you would like to see industry avoid as it tries to create commercial value out of satellite Earth observations?
Great, thanks, Harry. So on the first part of that question, in terms of what governments should be doing more of, I think what often happens at an institutional level is that there isn't a policy framework, for one, in terms of how institutions are able to better collaborate. But generally speaking, when we're looking at Earth observations data, it's usually the expertise for that is within a certain few agencies. But many of the issues that Earth observation data really applies to is very cross-sectoral. So institutionally, there needs to be better collaboration across institutions to make those data and methods available. In terms of the private sector, I think there's a lot of capacity that's required at the country level in order to be able to have access to the services and technology that private sector is continuously innovating around. But at the same time, often we get stuck in a situation where there's more supply without understanding what the actual demand is that's happening on the ground. So what I think private sector can do more of is, as we're thinking about the various products that are being made available, we're making sure that that's fit for purpose, where, when we're talking about the different resolutions of Earth observation data, that they're applicable to the particular questions and problems, and being able to help countries really be able to apply the data in a way that it's really solving for the particular challenges that are on the ground. Thanks.
Okay, thanks. Okay, my second question is for Stuart. What are you not able to do as a government organization that you would really like to be able to do, and what role do you see for industry in that?
Governments aren't very good at delivering the last mile of products and services in terms of the examples I showed you are of products that we can deliver from the Digital Earth Australia are really important for government decision making, and they're answering the problems that governments might have about managing our water resources, assisting with tracking our agricultural productivity. But the real opportunity exists for industry to take that and take it and value add to it and take it further. So what we are keen to encourage with Digital Earth Australia is a whole ecosystem of startups, commercial vendors that actually take our information that last mile to specific users that will actually use it for their specific needs. So a great example is I showed you the farm tracking capability. We might be interested in, from a government perspective, in forecasting the wheat crop for South Australia, but we're not necessarily interested in providing the manage your farm application that you can imagine coming out of that work. That's where we want the private sector to come in and develop tools and services on top of this capability. So government does the infrastructure, the core infrastructure, the private sector then takes that further to delivery to the individual consumer.
Great, thanks. Question 3 for Grega. Many new companies and ventures are proposing to sell more types of Earth observations. However, your business is based on free and open government-funded observations. How do you see that seeming conflict evolving?
Well, I think that the challenge is really more for the commercial data providers, because there's so much of the data now available for free, and the data is really good, that it's becoming a challenge to actually charge something to it. I mean, from our point of view, we don't work only with the open data, we also work with the commercial data. So we have We have the agreements with Planet, for example, and Airbus, and we use their data. And as I have mentioned, the cost of the data itself is not really the major issue. The major issue is how to get this efficiently, how to get only what you want. I mean, we have customers and they are perfectly willing to pay, I don't know, 10 euros per square kilometer, but if they need to pay 100 square kilometers every week, that's becoming a challenge. So I think as the industry will, the Earth observation industry will improve, these APIs to get the data will become more and more tied to getting really the data that we need, and then we'll be able to integrate all of that, and that will be really, really nice.
Great, thanks. So my next question is for Brendan. What do you see as the big barriers or challenges for making private industry a major contributor for using satellite Earth observations to achieve societal development goals?
Well, so I think we already are. I think we're already contributing. So you know, in some of the examples that I used earlier, in terms of you know, we're hosting Sentinel data, we're hosting Landsat data, and making it available for free in the cloud. I think that is the beginning of contribution. It's not the end of the story, though. You know, but that thing that I mentioned a few minutes ago about being able to lower the cost of experimentation, lower the cost of compute, that's leading to some interesting outcomes in places like Africa, where, you know, we're working with a group, we're actually working with a group at the University of Nottingham and the World Bank, where, you know, they're building up a corpus of geospatial data about Dar es Salaam in Tanzania, and actually using that as a way of doing planning, urban planning for, you know, World Bank investments of hospitals and stuff. So there's an engagement, there are already engagements going on a commercial basis. I think at the broader level, though, to actually really affect this change and to really get this to stick, I think, you know, perhaps there's a couple of other things that need to happen. I think in the research space, you know, and where a lot of this data comes from, we need to perhaps change some habits of a lifetime. Instead of, you know, warehousing large slabs of data on, say, a national supercomputer, which is inaccessible to most of the public, we need to start getting that data out there in more forums. You know, and obviously I've got a pretty strong opinion about where I think the best forum is, obviously. But the other thing I suspect we all need to do and mature as an industry is perhaps to be not so afraid of commercial activities and commercial engagements. So we will reach a point where we have to accept that data does have a cost, right? Data isn't free. Certainly those satellites cost an awful lot of money. Just the data storage and the data transmission costs an awful lot of money as well. We shouldn't fear data having a price on it. I don't think much of the world has really figured out a really good way of tariffing or pricing data, and I say that across most industries. I think that's true. I'm not proposing a sudden breakout brilliant solution here on the stage this morning, but the virtues of coming up with some acceptable data pricing models in different industries and in different domains, and I think EO is clearly data heavy, one of the most data heavy domains I work in, apart from maybe bioinformatics and astronomy. If we can, as a community, come up with a sensible and rational way of putting some price on data, you know, and it doesn't have to be a high price, that can actually produce a sustainable economic model, and it would actually encourage, I think, governments who are, you know, frankly, you know, sources of enormous amounts of data in this field, to actually get that data out there. You know, a lot of folks are afraid of putting data out there in the public domain just for the sheer cost of the infrastructure or how expensive or time-consuming it might be to stand all of that up. If there was an economic model around it that was sustainable, I think it would be, it'd be profound, because we would see an explosion of not just the volume of data that's available to the commercial sector and the public and other researchers, but also types of data. And that would mean that not only is it geospatial data, pictures of the Earth from space, but it also could be, you know, locations of, you know, health data. so that we could actually correlate perhaps weather events with health risks, with mental health implications, etc. And that's where we will really see a huge impact on our society, is being able to glean insights into that stuff. So we shouldn't fear data getting a price, because it will actually, I think, lead to an explosion in exactly what we want, which is the availability of that data.
Great, thanks. And I think Stuart has a quick follow-up.
Yes, I wanted to nuance that message a little bit with an example, because I mentioned in my presentation the fact that Landsat data used to be charged for by the US government. It was charged a lot cheaper than commercial scenes at that time. It seemed like a good deal, $1,000 per scene. But what I highlighted in my presentation was that the sort of use that we're making of it now was completely unavailable under that pricing regime. I'll just highlight that the experience the US government had, at its peak, when they were delivering, or when they were charging for Landsat data, they were only delivering about 50 scenes per day at its peak to paying customers, and in that peak year they made $6 million from selling the data. They did a study in 2013 looking at the economic value that had accrued since they actually made that data open, and they just in that year of 2012 to 2013, they looking across 5 industries, they found that the economic benefit to the US economy of the use of Landsat data was $1.8 billion. $1.8 billion in that 1 year, and that was enough to fund the entire Landsat program back to its beginning. So we've got to be very careful. I agree that we shouldn't be afraid of pricing data, but we've got to be very careful about the mechanisms we use to do that, to ensure that we're looking at the whole picture. And the whole picture is not just what you get back for selling the data, it's actually what the economic benefit of the use of that data in the broader economy is. And governments can afford to provide data as infrastructure, free to the end user, because of the economic value that it brings into the broader economy. So we've got to be very careful about taking that step and not learning those lessons from the past. Thanks.
Great, thanks, Stuart. Okay, now for some audience questions. Aditya, what can the space community do to make our data easier for countries to use to drive sustainable development?
Thanks, Harry. Great question. I'll offer some insights. I imagine that some others will have some input on this as well, but I think it comes back to the point of I think we all have a tendency to be very siloed in our approaches, and in relation to the Sustainable Development Goals, it's going to require a cross-disciplinary approach. And so one thing that I would encourage is to really get out from your own communities and be talking to other organizations and sectors, because it's going to require your knowledge and methods as applied to what's happening within agriculture or health or water and so on, where being able to really help others understand how this data can best be applied really comes back to really understanding what the challenges and the demands are. So become more oriented around really understanding, once you've made all of the investment and how that data is being collected and produced, really focusing on how it's going to be applied and used within the different organizations that need it.
Great. Anybody else want to comment on that one? Okay, let me go to the next one. Okay, as the diversity of data types increases, how do you deal with providing the metadata, data describing the data that is, in a way to efficiently allow data search and discovery across multiple data sets and platforms? So that question's for anyone that wants to address it. Go ahead, Stuart.
So I'll answer this in 2 ways. One is to say that it's not just about discovery. Discovery is important, but delivery and utility is even more important. Scientists are actually pretty poor at going through the process of filling in metadata. So that's important. One of the things I wanted to highlight here is it's more than just metadata, though, and what we've deliberately done with our Digital Earth Australia process is to track the provenance of the data all the way from when it's collected from the satellite into the end products, so that with every number that we generate out of those products, we can actually track back and tell you exactly what algorithm it's been through, on what version, which satellite overpass that particular number came from, and be able to actually track that whole value chain of how that information has been generated is just as important as having the metadata right, because if you're making decisions that might have legal implications for compliance or some other decision that's been made on policy, being able to actually track back the provenance of that information and how it was generated through what scientific process, and be able to replicate that number is just as important.
Thanks. Anybody else want to comment on that one? Okay, let me go to one more. And that's for any of the panelists. If you could ask law and policymakers to change one thing to help you in your day-to-day operations, what would it be?
Can I start? So one of the biggest issues that we see at the country level in what's creating a barrier for how data ecosystems get created is that there isn't really the policy enabling framework that allows institutions to better share data across institutions, but then also to make data more open and accessible. So I think one of the key policy enabling environments that's needed is for countries to really sort of understand the value, as you were talking about in terms of once data becomes open, and also the economic value that's coming back behind that, as a way to then really develop the types of policies that enable access to different data.
If I may add, what I think is very important is that when governments decide to share the data, they also need to really provide it under unrestricted license, so that the commercial entities like us can really do whatever we want with it. Because if we can just get the data and use it for research purpose, then it doesn't help much.
So we've got this, we've got these, internally we have this, we call it Jeds Law for open data. Get it out there, describe what it is, and make sure it's there tomorrow. It's that make sure it's there tomorrow that is of course the most important part, because it's it's the sustainability of that open data, which is, I guess, is really where I was going before with perhaps we have to mature some models, or more to the point, experiment with some models on pricing on that data. I totally take Stuart's point that that when government invests to make big data sets open and freely available to the public, that's incredibly important, because it is a government investment. But of course, there's other data sets that go wanting for that investment and that don't see the light of day. So I think from I think they could be freed up if there was a cost recovery model that the governments had available to them to charge a trickling amount of money to at least recover the costs of exposing that data. I think it's important for us to try and figure out a path to that. One of the things that always worries me about the digital economy growing up on large slabs of public data that's been made available for free from governments is the government's budgets are fickle. We, the taxpayers, get grumpy every now and again, and crank different handles on our voting machines and get different results. And so, a government department having a budget cut can undermine some of the availability of those data sets, and that we may have built a big digital economy on top of those things, and sometimes it's hard to keep government's attention on that investment that they made 10 years ago and why it's important to keep doing it. So that really probably means pricing on some data, figuring out, experimenting and exploring the problem space of pricing on data. No one's got a good answer.
Okay.
But also coming up with ways of making sure we keep reminding ourselves how important those big investments are that Stuart mentions, and how we keep those out there.
Thanks. We have time. I'm going to take a little risk here for maybe a very quick answer to what I think is a really interesting question, and this one's for Aditya. It says, how do you address privacy concerns at both the individual and national level, especially with regard to open data, as this could lead to national security concerns? Maybe Stuart would want to address that too, but we got to keep it very short.
I'll just say a couple of quick things. I mean, I think part of the answer here is also the metadata. You just have to be able to, when you're making information available, really be able to say what the use constraints and assumptions are behind that data and what the appropriate uses of that information is. And there's a number of different methods that allow for that, including how you anonymize and generalize data. We're working with a number of different institutions that are looking at the regulatory and privacy types of issues, especially in relation to call data records coming from mobile phones. So working with GSMA and the Digital Impact Alliance, who work with all the telecom providers, for example, to work through those issues. And then there's different ways in terms of how you can apply open algorithms, so it's not necessarily the raw data that's getting released, but all the derivative products that are coming out of that.
Stuart, 30 seconds.
Yeah, all I'd say is two things. One is that most of the free and open data is at still relatively coarse scale, so it's not getting down to the point where you can identify features, number plates, or anything else. Second thing is that in most cases, when we're talking about Earth observations and satellite imagery, it's stuff that you can look over your neighbour's fence and see anyway, right? So privacy is not the same in this space. If you can see it by flying a plane over the top of someone's land, then it's not private, it's just more accessible.
Very good. So most of our panelists will be available after the session if you'd like to follow up with them. Give them about 5 minutes after the session and go to Hall M, where they will provide extra time for you. We will also provide the audience questions we received, which we did not have time to answer in this session. So now I'd like to summarize to close the session by giving just a brief overview of what I think we learned today. So first off, satellite observations provide a wide range of societal benefits today, but we've entered a new era of challenge, change, and opportunity. Our challenge is that we are only scratching the surface of what can be done, and the techniques we have been using are not adequate to the ever-growing volumes of data available on the from the global observing system of systems. Our change is that we have to transform and use big data techniques, and we have to harness new ideas and business models to leverage the potential in the satellite Earth observations. And our opportunity is to maximize the contribution of the wealth of satellite Earth observations, that is big space data, to drive sustainable development and economic growth on Earth. Let's give our panel a big round of applause. Thank you very much, and again, if you'd like to follow up with our panelists, go to Hall M and they'll be available for up to an hour. Thank you.